It is Fox weather at night. It is a big night of aurora once again, especially up in the northern tier of the U.S. I don't think this is going to be quite as wide-reaching of a spectacular display as what we saw last night. You know, a lot of the day on Wednesday has been just kind of waiting to see what happens because we got hit by this blast of energy from the sun around mid-afternoon or so Eastern time, and then things have to settle a little bit. You got to see how is that energy going to interact with the magnetic field of the United States, or the magnetic field of the Earth. I don't think we have our own magnetic field. That would be pretty cool, though, huh? All right, this is a sign that I need to stop talking and bring in an expert here. Let's bring in Vanessa Polito. She's a research scientist over at Oregon State University, originally from Italy. So I'm really excited to talk to you about this because I have so many questions. First off, let's talk last night versus tonight. Are we at the point where we can have a pretty good idea of how this is going to pan out? Do you think we're going to make it pretty far to the south, or do we stay up in the northern latitudes tonight?
Yeah, that's kind of interesting question. I think it might be less intense than yesterday, tonight's storm. I think yesterday there were two CMEs hitting the Earth, and also the particle densities is a bit lower today, so it's kind of hard to say, but it might be a bit less spectacular than yesterday.
Yeah, I think that's the trend that we're seeing. You know, it's been, I'm curious why these things are so difficult to forecast, right? And I kind of mentioned this a lot yesterday. We had another expert on, and I was talking about how, you know, it seems like the forecasting with this is somewhat in its infancy, and we still have a lot to learn, which makes it very exciting to be in the field. You know, we do a good job. We can actually see the coronal mass ejections coming off of the sunspots. We can kind of track them to some degree, if I'm not mistaken, and then we know when they hit the Earth. But why is it so difficult to know whether there's going to be a display of aurora before it hits?
Yeah, so it is a complicated problem, as you're saying, because they propagate, and the models to propagate them and simulate the propagation can be really tricky to pin down. So there are lots of things that can happen in the CME between the time it gets released on the sun and it reaches the Earth. It can encounter more background solar wind plasma and gets like dragged down or interact with the solar wind. It can, depending on how it expands, it can also have more of a lateral expansion, so a lot of things can happen to it, and the models are a very complicated physics problem to address. The scales are huge. You are combining physics that happen on such a big separate scale, so that it is really challenging, and it's really exciting to be working in this field.
Yeah, I love it. I'm really a fan of your work. I just, you know, I started to dive into a little bit of it today, watching some of your lectures on YouTube, and it's very clear that obviously you know your stuff. You're an expert in the field, but you do a very good job of explaining stuff. Let's talk terminology a little bit here. Okay, so you've got sunspots. You've got solar flares, you've got a solar storm, you've got a coronal mass ejection. Can you just kind of take us from the beginning of the process to the end? As I understand it, a cluster of sunspots, are those actually solar storms that are going on already?
Yeah, so there are actually two separate things, like both solar flares and coronal mass ejections are manifestations of the solar activity, but they're different phenomena. So solar flares are like the largest explosions in our solar system, and they're associated with the release of energy, a tremendous release of energy. Think about like 10 million times a volcanic explosion. And basically, they are associated with the release of this tremendous amount of radiation, a lot of high energy radiation like UV light, X-ray, but they also associated sometimes with coronal mass ejections. So these are two separate things that did not always happen at the same time. The coronal mass ejections is basically a giant bubble of gas, of ionized gas that we call plasma, that gets ejected from the solar atmosphere. It can be huge. It can be like a quarter of the distance between the Earth and the sun in size. That is what actually is accelerated in the interplanetary space and reaches the Earth. But we can have effects from both of these. And not all the time we have flares and CMEs at the same time. So yesterday we had, in the last couple of days, we had flares associated with CMEs. So the first effect is from the radiation of the solar flare. So the strong UV and X-ray radiation that reaches the Earth in about 8 minutes. That's the time it takes for the light to travel from the sun to the Earth. and can cause things like radio communication disruptions that I think we saw yesterday. And then the CME can arrive later, and that brings a lot of huge volume of charged particles. And then we see the auroras and the other effects of the CME.
Okay, so speaking of charged particles, and that's a great explanation, there's one certain parameter that I feel like is very important that I've been seeing a lot in my social media feed, this thing called BZ. It's like a big B with a little Z right next to it, and for lack of a better thing to draw on, I'm actually just going to draw the graph here freehand. I'm just going to zoom into a place where there's not much showing up on the satellite, and we're going to draw the graph here. So the graph looks something like this. You've got the middle line, you've got the top line, and you've got the bottom line. Let me try this again. Hang tight. Sorry. Let's make them let's do a good drawing. I'm not very good at drawing. This is 0, this is 20, and this is like -20, right? So the CME hits, and you start to see some activity here, and for a good chunk of today, the activity was like up here. And then all of a sudden, right before sundown, it dropped down. And apparently, like, it's better if it's negative for aurora viewing. Why is that the case?
Yeah, so that might be related to the density of the particles that are reaching there. So like a more, and the direction actually is also the direction of the magnetic field of the CME, if it's aligned with the magnetic field or not. So there are some conditions that make the propagation of the charged particles more favorable. And then what happens is then when they get funneled through to the magnetic field of the Earth, and then they reach the atmosphere, and they ionize the atoms and drive the beautiful colors that we see in the aurora. So it depends on the configuration of the magnetic field of the CME and the density of the charged particles.
Okay, I was trying to do a little bit of research on this, and I had heard it explained like when the BZ is positive, it's like you're taking two magnets and trying to put both positive sides together, and they repel. And then if the BZ is negative, it's like you take the negative and positive, and then all of a sudden it latches on and you get the aurora. Is that kind of a good way to describe it?
Yes. That depends on the direction of the magnetic field of the CME, compared to the Earth.
Okay, so how about northern hemisphere versus southern hemisphere? All the pictures we saw from last night were from the northern hemisphere. We had a lot of stuff from the U.S., obviously, where most of our viewers are from. I saw some stuff out of Europe as well, Canada, obviously. Does the aurora display pick a side? Are there certain situations where it's more favorable for the northern hemisphere or the southern hemisphere?
Yes, I guess it depends on the direction of the CME when it gets released from the sun, and where the Earth is in that moment when it's gonna hit the CME. So we've seen more of the northern lights this time for the type of configuration that we have on the CME.
Fantastic stuff here. One more thing. So our KP index. So I think we're at a G3 right now, with maybe a small chance of getting to G4, but probably staying at G3 if I'm not mistaken. Again, please correct me if I'm wrong here. Last night we were at we were at like an 8 or 9, something like that. So I'm sorry, this is the KP index that I'm talking about, which is kind of oriented with a G4, the 8 or 9. It's a lot of numbers and letters to get straight, but I'm sure mathematicians have a better mind to deal with this. But the view line here, and we get down to 9, at least in general, it kind of goes through the central part of the U.S. But last night we saw stuff so much farther toward the south. What are the different factors that can determine how far toward the south it gets? It's not just KP index, right?
Yeah. So I guess how deep it depends on how deeply the particles can reach into the Earth's atmosphere, where they get stopped. I think it depends on factors including the size of the CME and some other things like that. So and how strong it is, the flare, and that the energy that was driving the CME in the first place. These are all things that.
I'm sorry. I didn't mean to cut you off. We are running a little bit. We're running a little bit short on time. I'm so glad that I got to meet you. Thank you so much for clearing so many things up. You were fantastic. That's Vanessa Polito, University or Oregon State University, I should say, research scientist. We'll have you back at some point. Thanks so much.
Thank you.
All right. Look at this. We just got to do a couple more nights of this, and I feel like I'm going to be an expert, right? It's almost like going to college. You get like a little personalized lecture every single night on stuff you don't know much about. I love it. Let me real quick show you the cloud situation that we have right now. So, long story short, all right, I know that last segment was really kind of for the geeks. All right, there are a lot of people that have questions about all these numbers and letters, myself included. Tonight, differences between tonight and last night. First off, tonight, it's not going to get as far south. It will not be, at least it doesn't appear that it's going to be as spectacular of a display way down toward the south. Now, I have seen a couple of pictures tonight from reputable sources in Kansas, Oklahoma, Texas, but I don't believe that they were visible with the naked eye, and if so, just barely. So you can maybe get out there. I mean, if there are no clouds around, if you're in Missouri, if you're in Kansas, get out there, take a long exposure shot, and you might be surprised at what you see. We've got a pretty spectacular display going on tonight. This is from tonight, Chris, I assume? All right, great. This is up in North Dakota from the Bakers, and yes, we can totally confirm that we've got good stuff going on in North Dakota. A little bit of a difference also tonight in the colors. You notice that, Chris? I maybe should have asked Vanessa about that. But we do know that the green and the red colors come from oxygen particles. And then the blues and the purples, they come from nitrogen particles that are a little bit lower in the atmosphere. And I say relatively lower because all this stuff is like way above where planes fly. We're talking like, hundreds of kilometers up in the sky. So last night we were seeing some super spectacular greens. That's live in Inkster. So in Inkster we're seeing the spectacular greens, and then you saw that other shot from the other city in North Dakota where you were seeing some pretty solid purples, where we saw a lot of the purples last night in Seattle.